right. Hello. Welcome to our next talk here at JNation. Thank you for coming. Thank you for having me first time in this conference. It looks amazing. I love the visual style with the steampunk and everything. I don't know if someone gave them any ideas, but okay. It works quite nicely. Okay, we're going to talk about a conspiracy today. I'm going to prove to you that DevOps is a conspiracy of system administrators and ops people against us, the developers. And I have proof. First of all, let me just check that I'm in the right place. How many of you are developers? Okay, everybody are developers. My people, great. Okay, so I don't know if you know what DevOps is. No one knows what DevOps is. People who get jobs in DevOps have no idea what DevOps is. I'm going to tell you all about it. You will know exactly what it is, why it's there, and what's going on with it, so don't worry about it. My name is Baruch. I'm the Chief Sticker Officer at JFrog. That's my official business card. I have those. This part is a sticker because sticker officer. We have a booth upstairs. Amazing t-shirts, by the way, and amazing stickers. Obviously, if you still didn't visit, come and visit us. DevOps, JFrog is a company that does tools for DevOps. This is why I got into DevOps, and this is why I can tell you all the dark secrets about DevOps. Right, so yes, I work in a DevOps company now, but if you look back, like way back, 2004, I was a developer, and you know how it works. Once a developer, always developer. This is why I'm in this conference and not in some DevOps conference, because I'm a developer, working in disguise, undercover, in DevOps company. This is what I'm doing. So, okay. Let's start building the case that DevOps is a plot of ops people. For you to really understand that, we need to look at one of the most important books in DevOps, which is called the Phoenix Project. When you want to learn about DevOps in kind of a less technical and more fun way, you read this. It's a novel, actually. It's a very lightweight non-fiction reading, fiction reading. It's not like your regular technical book. And it's fun, it's engaging, and it's a great story. I really recommend this book to start learning about DevOps. The story here is that there was a protagonist who was working in a struggling company and then kind of invented DevOps and won with DevOps. Turned the company around, propelled his career, saved the company, all thanks to DevOps. Now, to understand what this book is about, we can look at the cover and see who are the main characters in the book. So we'll start over there. Patty, she's director of IT service support. She's an ops person. And then we have Wes, Director of Distributed Technology Ops, obviously an ops person. And then we have SVP of Sales, and then we have CEO, and then we have a CFO. Fine, this guy, Bill Palmer, he is the main protagonist. He's the one who invents DevOps and wins, VP of IT Ops. He's an ops guy. And then we have a board member, fine, Brent. Brent, he's the most respected technical person, and he is a system administrator, ops. And then we have John, who is a security person, fine. You know who's not here? Seriously. I mean, a book about DevOps, not a single developer on the cover. Developers are mentioned in the book, not in the best of lights, I can tell you. They're pictured in people who wrote the code and then kind of don't care about anything else. They're like, done. Here's your code. Go ahead and struggle with it. And this is where, all the story of DevOps starts. After you finish the Phoenix project and you kind of figured out that developers is not a real part of it, it's all ops story, you want more proof, you go to the next book. The next book is the DevOps Handbook. They already have a second edition out. That's a cover of the first one. Doesn't really matter because the authors are the same. And what I want to talk about here are the authors. So Jin Kim. Jin Kim, we just spoke about his book, The Phoenix Project. He kind of the co-author, but there are 3 more. Let's look at those guys. Those 4 are kind of the fathers of DevOps. So when we look at their background, it will tell us a lot about where DevOps come from. Right, so Patrick Dubois, he worked as a system admin and then system architect forever. He's an ops guy. Jess Humble actually wrote a book called Continuous Delivery, one of the most important books in the ops space. And he was deputy director of delivery architecture when delivery is obviously an ops concept. He's an ops guy. John Willis, my dear friend, actually worked at a company called Ops Code. Right, you cannot get any more opsy than that. He's a very ops guy. All 4 of the fathers of DevOps are all DevOps people. Now, who preaches us DevOps today? Let's look at who pushes this agenda. What is DevOps in Google? New Relic, observability platform, tool for ops. Amazon Web Services, ops platform. CollabNet, they have some developer resources, fine. The Agile Admin, do. DevOps Wikipedia, fine. Atlassian, DevOps company. Microsoft Azure, delivery like cloud DevOps platform. And then towards the end, it's a Logs.io, which is observability platform. Whoever preaches DevOps to us, they're all ops companies. I think it's proven by now. When we hear about DevOps, it's all ops. The reason is what the interesting question is why. Why they push DevOps so hard? You might think it's all about, first of all, it's all about being a DevOps engineer. What is DevOps engineer? Here's a great answer for you. How do I switch my job from system admin to DevOps? Well, basically, you are an admin, and then you learn a bunch of stuff. Cloud computing, DevOps fundamentals, blah, 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 something that is called Gits. And then, boom, you are a DevOps engineer, which is nice, because you used to earn this amount of money being a system administrator, and then you switch, you learn Gits, you become DevOps engineer, and you earn this amount of money. Nice trick. You might say, hey, that's probably about that. And you know what? The demand is amazing. 1,500 jobs in the United States alone for DevOps engineer. More money, a lot of jobs, sounds like fun. And you know what? People get into this thing. Okay, we can earn money here. Let's do certifications now for DevOps engineers. Fun! More money. Well, it's not that. It's quantum entanglement. It's when we confuse the result with the cause. Money is just a result. It's not why DevOps came to be. Why DevOps came to be? Because of this. This is the DevOps infinity loop. You go from planning to coding to building, test, release, deploy, operate, monitor. Great. Now, you might see this and say, hey, this looks very familiar. Anyone has any ideas what it looks like? What it reminds you of? This. You wanted to say that? Here you go. This. It's exactly the same thing, right? We go through plan, design, develop, test, release, feedback. This is about developers. What DevOps do is say, hey, do all that, but also our part. Right? They just took what we used to do as developers and added their work and say, okay, now it's all yours. Go ahead and do it. But what they really mean is it's all ops. State of DevOps report. This is the most important research that is done in DevOps space. Every year, year after year, they ask companies about how they do DevOps, and they come with smart conclusions about what works and what doesn't, and why we need DevOps. No sarcasm, no joking. If you want to learn about DevOps, this is important. Now, this is rather old, 2018, and I look at this old report for a reason. We will get to a new edition later. Let's look what, according to State of DevOps report, is DevOps. What's it about? Aspect of software delivery performance. How do we measure successful DevOps? Deploying, taking from after the code is written to production, outages, and degraded service. It's all ops concepts. There is no developers here, nothing about actually writing code. This is a very important table, and you can see how DevOps is important because for example, elite performers spend at least double the time comparing to low performers working on what is called new work. And you can understand how new work is important because new work is where the money is. Everything else is just improving what we already have. New work is where the money is. The question is, how do they define what new work is? Types of work in the Phoenix project and in the State of DevOps report. Planned work, that's the new work. Business projects and new features. We understand that, right? This is where we write new features. The rest, internal projects, server migrations, software updates, that's not ours. Changes driven by feedback, fine. Unplanned work, support escalations and emergency outages, that's not ours. It's all ops, right? I mean, it's very interesting, it's very important. It's like we're all into that. It's just not our job. It's all ops. What is our job? We either work on new features, or we fix bugs, or we do refactoring. All these outages and server migrations and all this stuff, it's not ours. I guess you see it right by now. DevOps really is an ops concept. It came from ops people. It talks about ops concepts. It's all about ops. And the only reason it exists is to make us, the developers, work more for the sake of ops people. Nah, not the brightest idea. But let's get back to us now. What do mean for us to do our job? There are a lot of definitions, and this is one of them. It's Manifesto of Software Craftsmanship. There are a lot of questions about people who wrote it and what's not, but I think the concepts are very solid. If you look at them, not only working software, but also well-crafted software. We care about quality? Of course we do. Not only responding to change, but steadily adding value. We want to make our software better proactively? Of course we do. Not only individuals, but community. Of course, we care about that. Not only customer collaboration, but productive partnerships. I think this resonates with each and every developer in the room because this is, for us, what an excellent developer job is. This has been broke down in many conference talks, including this slide that I really like from a talk by Anton Keks called The Polyglot Developer. And this is what or a full stack developer. And this is what it means becoming a full stack developer. You need to know about technologies, you need to be a polyglot developer, you need to learn the essence of what you are doing applied to any language, you still have deep understanding in different parts of technology, you have design structure and everything. And there is an ops part into it, almost like an afterthought. It's here in the bottom, like a last bullet. And also look what's the reason behind caring about deployment, so you won't be called in the middle of the night. Not that you really care about that. You just don't want to wake up. This is all, I mean, our relations to deployment is just leave us alone. Makes sense. What do we consider done? Understand what needs to be done. Our code is readable, simple, understandable. Our code is easy to deploy. Non-functional requirements are met. We didn't incur any technical debt. Our test pass. QA took a look and they're happy. Quality is important. Team lead took a look and they're happy. And product owner took a look and they're happy. And product owner here kind of represents the customer, so we consider that the customer also is happy. Right? I guess you're with me on this? Looks good, looks comprehensive, good. All right, so I don't know if you remember, back in the day, there was like stupid notion that the developers are at war with the testers. I mean, it's ridiculous because, as we just mentioned, quality is important to us. And that means that the testers are not our enemies, but actually our friends that help us make our software better. Every time the QA finds something, it gives us the opportunity to make our software better. And that means that we love them, we embrace them, we want them to do their job because it helps our job. Sounds good? Agree? Perfect, great, okay. That means we care about quality. And that's a good thing that we care about quality. The question is what quality is. To answer this question, I want to take you back in time. This is the website of my bank 10 years ago. You can see Flash doesn't work anymore, right here, and this is fine. But all the rest actually looks like decent 10 years ago. I can log in, I can probably see my balances and my transactions and much more and what's not, but this is pretty much it. If I want to do 10 years ago something meaningful, I take my sheet and I go to the branch because this is where I can do something meaningful. The website was nice, but it wasn't critical. So when I see here in news and announcements that there is a maintenance window of 12 hours for software updates to ensure quality. I get it. I mean, fine, you want to do better site, it takes you 12 hours to update, fine, I don't really need your site anyway because I'm going to the branch if I need anything. Now, obviously, I know and you know that this era is gone. Last time I switched banks, it was because I didn't like the mobile app of the bank, because this is where I do my business. I don't remember last time that I went to the branch, and I have no intentions to go there for anything because everything is now online and in the apps. I really don't need it. The definition of quality changed. It was okay then, it's not okay now. That means that our quality needs to be top-notch because no one is going to tolerate those things. The problem is that it's not only about our code. Those days, to ensure quality, we need to take into account the data. And the data is going through the roof. That's a study from Seagate. They're kind of biased, but okay, you can factor in whatever their bias is. By 25, and it's 3 years away, 175 zettabytes. Petabytes are a lot, and then there is exabytes, which are really a lot, and then there is zettabytes, which is fucking a lot. Really. And that means that we have more and more data in more and more companies that makes our testing to ensure quality harder and harder. Because remember the blissed days when we just used a staging server that looked and felt and behaved exactly as production server, and we could test anything on it, and then if it works on the staging server, we're done. It will work in the production server with exactly the same quality. Well, this means that staging server is dead. It means that we cannot test everything in staging just because it doesn't make sense. We have so much data in production that we cannot, or it's not worth it, to replicate it in staging. And you know what that means? That means that we are going to test in production. What can possibly go wrong with that? To test in production, there is now a whole new industry emerged to test in production. And this industry has a bunch of very cool terminology. All of it, it's kind of around this progressive delivery thing. Progressive delivery thing means we are going to throw untested or not completely tested software in production and see what happens. The term that I really love on this slide is blast radius. Why do I love it? Because it's on point. Blast radius is, you know what it means. You have a blast, a bomb or something, and then there is a radius in which people are dead. Blast radius in progressive delivery is exactly the same thing. You throw an untested software or less tested software to production, and then there are casualties. What progressive delivery tries to do is to minimize the blast radius. Minimize is important because it doesn't mean eliminate. People will suffer. We'll just try to make it as less people as possible to suffer, and this is why progressive delivery is important. But basically, yes, everybody admit, we are going to throw untested software to production and see what happens, expecting casualties. And that's fine with everybody. And I guess if it's fine with everybody, it's fine with us. We're now testing in production. And if we are testing in production, and follow here my train of thought, if we are testing in production, and being in production is what's needed to ensure the quality of the software, and we already established that the quality of the software is important to us as the developers, it means that now we care about what happens in production. And if we care about what happens in production, that means we have to be there when we throw untested software on unsuspecting customers in production and observe from our bunker the blast radius. We have to be there, and that means we need to be on call with the ops people in the middle of the night when things go boom, because suddenly it's not only their concern, it's our concern, because this is the first time we actually get to test our software. Fun. Now, that also means that we have to add a new item to our list. And this list is something weird. SRE took a look and they are happy. Let's unpack this thing. Who are those SRE people and what they are doing? So SRE is a term that Google came up with to give a technical meaning to this notion of DevOps. DevOps is a methodology, DevOps is like a collaborative culture, DevOps is about mindset transformation, blah, blah, blah. Where is the money? Where are the engineers come in and make things better? Here they are. Software reliability, site reliability engineer, or as they lately called, service reliability engineers, are the people who implement DevOps. They are people who are in charge of whatever happens during night when we deploy to production. So when we established that they depend now on us and they kind of give us the feedback loop of our quality, suddenly we care about what they have to say. And what does it mean? What are their requirements to our software to be successful in their job? And that means us being successful in ours. First of all, we understand how our code is going to be deployed. Why it is important? Because remember, it's 3 a.m. in the night. There are casualties out there, blast radius. We need to roll out new version of our software with fixes of our own bugs, we need to understand how it is going to be deployed to production to do it as fast as possible. The build is reliable, repeatable, and fast because we need to build 3M reliable and fast. Our code is stateless. Well, there are opinions what scalable means. It has to be scalable anyway. Our code starts fast and dies fast. Starts fast, obviously, we just released a new version. It needs to go online as fast as possible. But also dies fast. We need to kill the buggy version as fast as possible. Our code is observable because we need to know, everybody needs to know what's going on with it so we can find the next bug and then fix it as well. Our code supports feature flags. Feature flags are nice. It's the way to turn off the buggy part of our software so no one knows it has bugs. Pretty neat. Our code backwards compatible, obviously. Now we have a new version of one microservice. It should work with the old versions of the rest of them. But also forward compatible, because now we rolled back a new version of our microservice to the old one, because the new one has bugs, but all the rest of the microservices are newer, so it has to be forward compatible. Good luck with that. And event streams are fine. Now, this is a list that you might say, oh, ops concerns. But no, they are your concerns because, to remind you, this is what you need to ensure quality for your software when it runs in production. So you care about this stuff, starting like now. This looks also very familiar. There are different ways to express this list. One of them is the 12-factor app. The 12-factor app, it's another manifest that describes how cloud-native, scalable software should be written in the modern era. People implemented that, and it's the same list, and then they call it, well, that's not enough. So let's come with more factors. 16, 14, 18, whatever. For some reason, they're all even, and some of them are power of 2, but there are tons of lists that describe the same list that I just gave you. There is one more thing here. Our code is lean. Lean like in saving money. And you go like, and what? What it has to do with me? Ops spend their money on this crap. This is not what I care about, right? Wrong. Here's an example. Kafka Summit 2019, talk by Uday from SignalFX, now Splunk, about how they implemented Kafka. You all agree that Kafka is our concern. It's a framework, it's a tool that we all use as developers. And look at this. Kafka saves in cross-availability zone network costs. Kafka actually reduces the cloud bill that those guys get from Amazon every month, and implementing Kafka saves money. Now suddenly you care about money, you care about savings, you care about business. So next time your hairy-pointed boss say, we need to cut costs, and the usual answers will be, let's do layoffs, or you know what, let's charge for coffee. No, we can do better. We can switch to serverless and go to cloud and save money. And by the way we write software, we can save our company money. And that's pretty awesome. So next time you're worried about layoffs and paying for coffee, instead, learn how to pronounce kubectl, which is the control command of Kubernetes, and start saving money for a company instead of the other ways of doing that. And then your hairy-pointed boss asks, we need more happy customers. Let's see what we can say there. Those are customers, and what do they want? Your customers, what do you want? New features. When do they want new features? Yesterday. How can we deliver features faster using our skills as developers. DevOps. This is a picture from the same DevOps State of DevOps report, and look what happens. Elite performance. Deploy code 208 times more than the low performers. Companies that implement DevOps deploy more frequently new features to their customers, making their customers happy. And then the pointed hairy boss asks, what about security? We need to improve security. How do we do that? We have our normal way. We hire Chief Information Security Officer, so we'll have someone to blame next time we have a data leak. Or we do DevOps. What DevOps has to do with that? Here is the diagram that you might see when you apply for a driving license and learn the theory. This is stopping distance, which is built from two very different concepts. There is the thinking distance and the braking distance. They are completely different. Braking distance is physics and chemistry. It's about how well your brakes are applied to the wheel and how well the rubber applies to the pavement and how good the pavement is and everything else. Thinking distance is about, well, also kind of chemistry, but chemistry here. It's how fast the signal from your eyes that you realize that you need to brake translated to the signal to your leg that you need to apply the brakes. Those two very different things together give us one result, the stopping distance. What it has to do with security? Reactive security is exactly the same. When you have a security incident, you need to identify it as soon as possible, one type of activity, fix it as soon as possible, basically writing code, this is what we do, other type of activity, and then update the software running in production, this is a third type of activity. All three of them are critical to react as fast as possible. And you might say, well, Baruch, don't do reactive, just do proactive. Just make sure that your code is safe, which is obviously easier said than done, especially in the age of Meltdown and Spectre. Remember those? There were two pesky vulnerabilities on the CPU level, and when Meltdown was more in use because it was easier to exploit, it was also easier to patch. The problem, the long-lasting problem, is with Spectre. Spectre is nasty because Spectre is about a technique, not a particular vulnerability. The way Spectre works is it implies the speculative optimizations that the CPU is going to do by observing similar patterns in different software pieces. We analyze a lot of software, we analyze how it behaves on a CPU level, and then we can guess how your software is going to behave, because you know what? Your software is exactly like as everybody else's, unless you are a really, really shitty developer. Because best practices and design patterns are an important part of our job. And we take pride of writing out software exactly the same as the best of it, and this is where Spectre can attack. So the way to proactively protect from Spectre is writing a really, really shitty software. Unless you want to do that, there is no protection against Spectre. This is why reactive is important, and this is why you have to be able to fix as fast as possible, but also deploy as fast as possible. And this is where, 208 times more frequent code deployments means not only new features to your customers faster, but also more secure software. So what we see here is that, yes, DevOps is a plot that came from ops people and everything, but it's also an evolution. DevOps is a mean to an end, to actually many good ends. One of them is quality. We just saw how. The other is lean software. We just saw that. New features, faster deployments bring that. and security, again, you deploy faster, you're more secure. So in the end of the day, DevOps just delivers what every business needs. That means that you don't have a choice. Now when you realize that they tricked you into DevOps, it might feel uncomfortable, but it's too late for that. It's too late for that because business liked it, and that means you need to understand what that means. And that means you are in it. Now, you might say, okay, I know DevOps diagram, this is it. It's basically, this is what I do. I'm a developer, and now I need to learn to be a QA person and the ops person, and when I master all of that, I become this wonderful DevOps engineer. And you say, well, that's pretty hard because it's impossible. And I have good news for you. It is impossible. DevOps engineers, as ponies farting rainbows, do not exist. They do not exist because DevOps is about collaboration between people from different parts of our industry. And the term DevOps engineers makes as much sense as collaboration engineer, which means it doesn't make sense. It doesn't make sense because they do not exist, or the other way around. They do not exist because it doesn't make sense. Instead, what we have are T-shaped people. Not in this term, not in this sense, in other sense. T-shaped people actually means that we have something that we know really well. And that's for us writing code. We are developers. This is what we do. We need to also know about the other aspects of DevOps. We need to understand how the ops part of the house works, what deployment means, what observability means, what outages mean, how can we help. We need to understand how QA works, what types of tests exist, how do they run, what software they use. It doesn't mean that we have to become them or learn everything they do. We do need to take interest and learn this type of stuff. So how a developer can participate in DevOps? They definitely know how to pronounce kubectl. That's very important. And that makes you a little bit more of a T-shaped person. I promised you that I go back to the State of DevOps report. And this is also not the newest one. This is just 1 year after the one I told you previously. But I want to show you how this understanding that DevOps is not only ops, but the developers are into it, not only propagates for us, the developers, but also propagates for the ops people. Only a year has passed, and look how the picture changed. First of all, look who now participates in the DevOps survey. The biggest group are developers. Look how the performance metrics changed. You remember how just a year prior, everything was about after the code is written. Now, suddenly, we have an entire pillar of software development here. The penny drops that we are in that together. And the most profound kind of a proof that ops people now understand that they need developers in the picture is this book. It's called The Unicorn Project, and the same author, and you can see the same graphical language. It's actually the same story. It's a rewrite, if you wish, of the Phoenix project. Same idea. There is a person who works in a struggling company, discovers DevOps, turns the company around, and wins. But now, the main protagonist who actually discovered DevOps is Maxine, and she is a developer. Suddenly, the ops people realize that DevOps is not only about tricking the developers into doing things, it's actually about working with developers, and developers play a central role in DevOps. And getting back to this SRE thing, look what SRE really means. And that's, again official statement from Google. SRE is what you get when you treat operations as it is a software problem. Not only we are not dragged into ops concepts, it's the other way around. Ops people now have to learn how to treat hardware and operations as software. They come closer to us, to the developers. Now they need to be both ops and dev, which is obviously impossible, but they will try it, and they will become more like us. So yes, DevOps is an ops idea. There is no arguing about it. Funny story, we had our own JFrog user conference, Swamp Up, just 2 weeks ago in San Diego. And it is a DevOps conference because JFrog does DevOps tools. One of my speakers was John Willis. Same John Willis who was one of the people who were conspiring against the developers. I did this talk. He was in the crowd, sitting in the first row, and he was nodding the entire way. He was like, yes, it was a conspiracy. Yes, we tried to trick you. Yes. So I have the official approval that that's exactly what happened, and my theory is correct. But it doesn't matter. It doesn't matter because business liked it. Business liked it because it's quality, it's saving money, it's competitive advantage, and it provides security. And that means that we are in it together. But it's not as bad as it sounds because everything is code now. And obviously, we love code. We are the developers. All we need to do is follow the principles and practices, and we know how to do that. This is our life. So all in all, DevOps is more than okay. DevOps is fine. Now, we have 8.5 minutes for Q&A, and before we do that, there is someone who wants to answer a question, to ask a question. And the question of this gentleman is, what do we do next? I have an answer. We just wrote a book about it. Stephen Chin, that was here with you on the stage during the keynote, Melissa McKay, Ishel Ruiz, that you probably know, and yours truly, we wrote a book called DevOps Tools for Java Developers. This is a book for you to take what you learned today to the next stage. You remember the list that now SRE expects for you? All the answers are here. This is how you make your code to play better in this DevOps big scheme of things. And with that, now it's time for your questions. Thank you very much.
Okay, please raise your hand if you have questions. And yeah, if you are online, please put your question here where I'm able to track it down.
Okay, I stand between you and lunch, so I completely understand if what you want to do instead of wasting your time with questions is being the first in line for lunch. I get it. So no hard feelings if you don't have any questions. If you do, fire away. Okay, lunch is winning. I can see that. I get it.
Okay.
Lunch it is.
Lunch.
Let's run to the line.
Thank you.